In this video, we're going to talk about different properties of limits. So here I've written out a few. So the first property is if you have a limit as x approaches some value of two separate functions, you can split it up into the limit of f of x plus the limit of g of x. So you can take the limit of each function separately and then add them together. Same with subtracting, you can split it up and you can take the limit of both separately and then subtract. Same with multiplying. If you're multiplying two functions together, you can split them up, take the limit separately, and then multiply. And same with dividing. You can split it up, take them both separately. So what this means application-wise is if I'm looking at two functions, so here we have f of x, here we have g of x. If it says the limit as x approaches 2 of f of x plus g of x, we can take them each separately and then add them together. So first I'm going to do the limit of f of x as x approaches 2. So when I'm looking at that, on f of x as x approaches 2, what y value is the limit hitting? So remember for the y values, that's where like the two sides are coming together. So the limit here is going to be 2 because that's the y value that we're hitting at. And then we're adding on the value as x approaches 2 for g of x. So at x approaches 2 for g of x, the y value is going to be 0. So we've got 2 plus 0. So this limit is 2. Same thing for each of these. So as x approaches 1 for f of x, the value at y is going to be 1. And then adding on for g as x approaches 1. Here, because there's a jump here, our limit does not exist. So we're doing like 1 plus does not exist. So you can't really do that. So really we're just going to say this limit does not exist because for one of the two functions, if it doesn't exist, for the whole limit it doesn't exist. As x approaches 0 for f of x, our y value is also 0. So we've got 0 multiplied by as x approaches 0 for g of x. So that is going to be some decimal, but 0 times anything is going to be 0. I'm just going to call it 1.3, but 0 times anything is going to equal 0. So that limit is 0. As x approaches -1, so here we've got x is -1, so the y value here is also -1. And then we're being divided by the limit as x approaches -1 for g of x. So as x approaches -1 here, the y value is 0. You know that in a fraction you can't have a 0 in the denominator, so this limit also does not exist. So remember, DNE means does not exist. I know people sometimes get confused on that. So DNE is does not exist. Continuing on, here we've got limit as x approaches 2. Here we didn't use g of x. However, if they just give you an x, that means you can plug in 2 right away. So what we've got is 2 cubed and then being multiplied by whatever the limit as x approaches 2 of f of x is. So as x approaches 2, the y value is also 2. So you've got 2 cubed times 2. And when you evaluate that, you're going to get 16. And finally, our last one, they've already given us the 3. So we've got 3 plus whatever the limit as x approaches 1 of f of x is. So as x approaches 1, f of x is going to be 1. So the limit, or square root of 3 plus 1 is square root of 4, which equals 2. So that is the idea of how to use these properties when you're evaluating a graph. So now try your practice problems and see if you can do it.